Here we go. We have a question, length of longest Fibonacci sequence. So a sequence from number 1 to n is a Fibonacci like if it has 3 numbers or more and the current number plus next number is equal to the next to next number. So is it like Fibonacci only? So we have given a strictly increasing array of positive integers forming a sequence. We need to return the length of the longest Fibonacci like sequence. If 1 does not exist, we just need to return 0. A subsequence is derived from another sequence by deleting any character including none from the array without changing the order of the remaining elements. For example, 3, 5, 8 is a subsequence of this array. So suppose we have given this array 1, 2, 3, 4, 5, 6, 7, 8, and in this the longest subsequence that we can find is of length 5. So 1 plus 2 is 3, 3 is there. So the last two number summation is 5 and the last two number summation is 8. So this is the longest number, and in this the last two number summation is 13, which is not there. So we will just stop here, and we have total 5 numbers. And in this array there are many possible answers, but all the possible answers have only 3 length. So this is the question, and let's build the approach. So I have taken the same test case, and we're gonna find how many what's the biggest length of Fibonacci like sequence. We need to find the longest Fibonacci sequence length. So we have given this array, and first we have this, then we have this, and the summation is this. So we can go further. So we will take now these two numbers, and the summation is 5. So we have given these two numbers, and the summation is, what's the summation? Summation is 8, which is not there. So we just gonna stop here, and in this I have taken 1, 2 as my starting position, but starting position can be anything. So let's take, I have taken these two, then I can also take these two as my starting position. I can also take these two as my starting position, and these two also, and that's all from 1. But we can also start from 2. 2, 3 can be our starting position. 2, 4, 2, 5, 2, 6. So anything can be our starting position. Our I is fixed, then j will start from I plus 1 and go till n minus 1, and this will be our starting first value, and starting and our second value. So we have given first value and second value. What is the first value? It is array of I. And what is second value? Second value is array of j. So what will be the third value? Third value is array of I plus array of j will be my third value. If this third value is present in my array, how we gonna find it? So we gonna just use set, and it will simply tell us whether that number is present or not. Then this number will be first number, this will be my second number, and third number we will again calculate using summation of first and second number. So if third number is there in our set, we will go further, and we will apply while loop here, and inside this we're gonna change our first, we're gonna change our second, we're gonna also update our current subsequence length. So this is how this approach will work. Let's quickly code this. So first we need a set, and just add all numbers. We also need answer, we also need n, and we have I loop, we have j loop, and j loop start from I. What is my first number? First number is array of I. What is my second number? Second number is array of j. What is my third number? Third number is first plus second, and this is my current subsequence. So current subsequence length is 2 till now. Then we have a while loop, while third is there in our set, contains third is there in our set. So we have one more number. First thing is to increment our current. The next thing is to reinitialize our first and second. So first will now point to second, second will now point to third, and third we will recalculate using first and second. As we are inside a subsequence, this Fibonacci like sequence is there in our array. So using only this we can find our maximum subsequence length, and that's it. That's all what we need. Let's run this, and I hope so I have made a mistake here. Oops, I think it will work now. So we have an issue. So what's the issue? Answer, my third is there. So I found the mistake. The mistake I did is, so we are starting from I0, which is correct, but we are starting our j loop from I only. But jth character must be different, and it must start from I plus 1 and should not be I itself. And yes, let's submit this, and let's talk about time and space complexity. So this will run for order of n, this will run for order of n, and we have solved this question. So this is n square. Inside this we have a while loop. So this third what is the third? So we are adding first, we are adding second, first plus second, first plus second, first per second. So it will go exponential. So it will not iterate on each and every value. It will go exponential. First it will add 1 plus 1, then it will become 2. So then it will jump, it will more jump. So I will not go in depth, but it will be 1 cross 8 times of the previous number. I think this is the correct idea. And this will jump over some numbers, it will skip some numbers, and its total time complexity will be log n only. And its total, our function, this function time complexity will be n square log n, I can say. So that's all about the time complexity. Space is constant. In this, space is order of n, as we are adding all the elements in our set. So this will work, and this is accepted. But can we do better? Yes, we can obviously do better. So let's go to the whiteboard. So we have done this question. So this is our approach 1, and let's talk about this test case. So in this test case, what we have? First number is this, second number is this, our next number will be this, then our next number will be this, and our next number will be this. So this is our answer: 5, 10, 15, 25 and 40, right? Yes, but we can choose different numbers. Yeah, so if I choose this, so this is one of the sequence, then I can choose this also, this is one of the sequence, this also, and this also. Okay, then I can choose this number and this number, I can choose this number and this number, and it will continue till here: 10, 15, 25 and 40. But isn't it useless? Yes, this is useless, because this and this number is already used, and this is the previous number, this is the previous number, this is my ith number, this is my jth number, but there's some previous value already, there's some previous value already. So we can apply dp here. If ith and jth is already calculated, I have already calculated my ith and jth, and this ith and jth, on this ith and jth I have already traversed. So why do we traverse again? We can simply store this ith and jth. So we will just simply store every ith, every jth. So we're gonna apply dp here of n cross n, and we're gonna store every ith and jth sequence, ith and jth sequence. So after storing ith and jth, we know starting from this condition, starting from this ith and jth, we have length 4. So when we come again on this point, we're gonna just simply return, we're gonna not return, we're gonna just pre-calculate it. So this is pre-calculated value, and we can simply tell it that the total length starting from this ith and jth index is 4 only, because we have pre-calculated it. And that's all. And we can code this, but we can further simplify this. So how we gonna simplify this? Let me take this same test case. So it is 5, 10, 12, 15, 25, 28 and 40. So suppose my ith will be my last value of a sequence, of a subsequence. My ith value will be my last value. So let's suppose this is my last value of a subsequence, yeah, and this is my resultant, and 40 is the last value of my subsequence. Then inside this range, there is the length, there is some kind of length, and the length we need to calculate it. So we need to find two values whose summation is equal to 40. So the two values is 15 and 25, which is this and this. These two value summation is 40. Yes, right. So how we gonna jump onto that values? Can we apply two sum algorithm? Yes, we can apply two sum. The intuition will be same here. We need to find two values whose summation is equal to 40. So my first value is this, my last value is this. The summation is 32 or 33, which is less. So I will just increment my L. Now it is 38, which is still less. Now we have this. The summation is, what is the summation? Summation is 40, which is correct. So 20, 28 and 40. So what is the longest of 12 and 28? What is the subsequence that ends on these two values, ith and jth? As I have already discussed, we're gonna simply apply dp here, and we will simply calculate it, ith and jth. So what will be the jth and endth? Jth and end. So jth and end, dp of jth and end will depends on so jth and end will depends on this and this, ith and jth plus 1, right? Yes. So we have these two, first smaller then bigger, smaller and bigger. So I will add one more digit, this is the one more digit, and smaller and largest, smaller and largest. So this will be my approach. So this and this we have already calculated. So these two, 12 and 28, these two indexes is the largest, and before that we don't have any digit. We don't have any digit that makes to this L, no, or makes till this R, no, we don't have any. So this is one of the sequence. Then if we found L and R is equal to L and R, Lth and Rth is equal to is equal to my ith. Yes, we have found this, but there can be many more subsequence. So now we just gonna reposition our L and R both. We will increment our L, we will decrement our R, as we do in two sum problem. So this two, 15 and 25, the summation is also 40. So yes, we have found two more digits. And to jump on to 15, we already have 5 and 10. And 5 and 25, 15 and 25 is already pre-calculated. Yes, pre-calculated. We have already found our lth, we have already found our rth. Now it's time to find our ndth. So that's how this will work. Let's code this. Code will gonna be very simple. So we have a dp n and n. We have n. We also have answer. Then we have I. We also need L and R. While this condition hold, L is less than R, we gonna find this is not binary search. We don't need middle. We gonna apply two sum. So the summation will be L and R. If summation is less to my ith, we gonna increment summation. If summation is more than my ith, we gonna find and we gonna reposition our R. Now the summation is equal, so this is one of the answer. This is one of the answer. So what I have told you. So first thing, L, then R, then I, isn't it? Yes, first we have L, then we have R, then we have I. So we can write it like this. LR will be my R, my R and I will depends on R and I will depends on L and R plus 1. Yes, you're right, it depends. Then we will find another subsequence and another two values whose summation is equal to ith. We're gonna find one more subsequence whose summation is equal to ith, and that's it. We just need to return answer, and inside this we gonna find our answer to R and ith. And we have missed one thing. If I run this, it will not calculate. I think there's a mistake. So my L is here, my R is I minus 1, then I will find L and R. The summation is less than ith. We need more values. The summation is more than ith. We gonna need less values. If it is equal, then we are initializing our Ri. Our Ri, it depends on LR plus 1. Then we need we will need to find another two values whose summation is equal to my ith. Yes, and this should work, but it is giving me 0. So I figured out my mistake. The mistake I did is I am changing my L and R, then I am accessing, but it should be before changing our L and R, and it should work, but it will give me two less values. Because we are onto some values L and R, and it is not accessing those two values, so it is giving me two less values. And 0, the answer will be 0 if there is no subsequence. So if there is no subsequence, we just gonna return 0, and if there is subsequence, we gonna add two more values, which is our L and R. Now let's submit this, and I hope it will work now. Yes, then it is close to 100% beat. Let's talk about time and space complexity. So this will run for order of n, then this will run for order of n also. So the time complexity is n square, space complexity is also n square. Thank you all for watching.